Oh, hey guys, so one of the first projects we're going to be doing on this new workstation is sorting out something to hold these power boards. Now, just to explain, behind this wall there's a couple of double power points, and I've bought a couple of 4-point black power boards. Okay, these power boards both have keyholes slots in the back of them. I've got 2 on the left, 1 on the right. But they're fixed now behind this pegboard. I went for mounting the pegboard from the rear rather than the front, just for a nicer look and a bit more room to hang stuff later. So I've got the power in there, but I need to make a little mount for all of these. So obviously I don't want them sitting on this little double hanger here. So what we need to do, because I've used all 3 and already mounted all 3, we need to take some dimensions of this power board, get it done accurately so that we can design a little pegboard hook to sit up the top. So I'll just put one in like here and have that power board sitting right up the top there. And so I'll be able to feed that cable through, probably have the power board, sitting here or maybe on the other side. All right, I'll check how everything fits. All right, but that's gonna sit up here. Okay, so we can plug into it. So I wanna get all this geometry right so that we can design that. So let's take some measurements now, and I'll just show you how I, take some measurements for this kind of thing and then put it into SolidWorks. As I'm doing it, I'm gonna do it downstairs here, take the measurements, take it upstairs to the study a bit later. So just pull this out a little bit. I've got a bit of distance here. We do need some calipers, but we could probably do it without actually. Like this is big enough that a tape measure is going to be fine. All right, so we're going to get both screens in one here. Let's go. So firstly, let's just get the size and shape right. Now you can see with what I'm drawing, it doesn't need to be super accurate. All that's important is the dimensions and the notes. So there's going to be this little cut there as well. And I'm just going to draw the depth in here. From the side view, okay, we can see that chord sort of comes out on the top. I'll take a dimension of that. I will get these 4 points in as well. They're times 4. I'll spread them out. So I'll just find like a center line for each, okay? Make sure I got my depth, and then the keyholes on the back is going to be pretty important. So let's have a look. There's some dimensions. This is 230 end to end, 230. The width is 49. There is a slight chamfer on the profile, so as I'm looking from this end here, I will draw it. It's got a tiny little chamfer on that side. Plastic comes down, split line between the top and bottom, coming in and across. Fill it on the sides. So the height of that part, you can say that is 25 millimeters. That chamfer looks like a 3 millimeter chamfer. The split line, just for reference, I put that at 8. The fillets on the bottom, this might be important, but it's something that we'll probably 3D print a bit later. I'm going to give that a 10 millimeter radius for R10. Okay, and then the cable thickness, cable comes out of that split line, so that's good. Cable thickness looks about to be, we'll make an 8 mil allowance for that. There is a reset button on the bottom, so we'll just note where that is. And that button is, again, it's 8, and we can measure sort of center to the edge. It's not that crucial. So from there to there, 36. And then our 4 points, you can see they are all, that looks to be like a 45 millimeter apart. Yep, 45, equal, okay. And what else do we need? And we'll just get one of them from the end, 29 mil. All right, so, that's covering off all of our dimensions. We're a little bit bigger on this end. Let's just say that height at that end equals plus 2 millimeters more. It's a little bit more than that actually. So this end, and it's got a bit of a curve to it as well. So maybe like 4 millimeters. So it's 29. So that's where this top face, it's like scalloped out. So it's flat there and it comes up a little bit on this. That's cut down. So we'll probably draw the whole thing at this height here and then slice off that bottom. Now the most important stuff is on the back. So make sure we get it the right way around. So keyholes, ignore the screw holes, it's the keyholes I'm worried about. And for this, I'm just going to thin out my drawing. So we've got circle, slot, and then we've got 2 of these. This I will get my calipers for. Let's come back and do that. Go back with the calipers. So the circle, you can see here, I'm getting 7 millimeters, 7.1. The slot, width, 4.1. That's going to be the same for both. And then the length of the slot, I can just go from the edge of the circle, 11.9. Okay, and that's going to be the same for both, I'm pretty certain. Yeah, 12. We can also measure the depth. I'm getting 4.7. And then distance between the two. We'll get the center point to the center point. 91, 92, 91.5. We can go outside to outside, might be more accurate. 103.2. Okay?
Dad, can we get some lollies?
Yeah. So we've got 103.2 from there to there. All right, that should be enough. Let's go chuck it into CAD. All right, welcome. Back now at the computer, ready to put this into SolidWorks. I've got my dimensions that I took on that sketch, as you can see here. And I've got a reference photo plus reference videos. The 3 units that I bought, they're all mounted, so I can't really take them out. A bit of hassle. I think we'll be able to get close enough without referencing them again. But if I need to, or when I do complete my 3D print to mount them, I'll just check the fitting. And the process that we work through here, the only cost to us really is time. So if I need to print 2 or 3 times to get the size right, we'll just do it to get it right. So let's go through the process now of getting this into CAD. I will just keep this image down here at the bottom of the screen so you guys can see what I'm referencing. And let's build. So we're going to start on top plane. Now just turn on my shortcuts as well. Okay, top. And we'll start with the overall dimensions. So we're just right now, we're going to go from edge to edge. Okay, and just get that whole profile in, and we might even position those outlets too. It is a straight slot shape, so we can use that tool. The dimension, I was looking at 49. Now, if you didn't know this, SolidWorks can do your maths for you. In this instance here, I'm dimensioning a radius, but I've measured a diameter. To put in a radius, I can put in 49 divided by 2 and hit enter. It'll work it out for me. And then my complete length, 230. So to get from end to end, if I just click sort of on this circle, it's going to go from the center point, so I don't want that. But if I hold shift when I do it, click, click, I can go 230. Okay. Now, while we're in this sketch, we'll also draw in the secondary arc as for construction. Do we have a dimension for that? Not sure. I might have to go back and find a dimension for it. We'll put a placeholder dimension in. I'm going to say 25 millimeters and just mark it so that I know to come back for it. Okay. And let's put our little power slots in so we know where they are too. I haven't measured them before, and all that really matters is the distance between them. It's just an approximation, so 10 by 2. I've probably modeled a power outlet before. In fact, I know I have, so I could open that up. Let's see if we can find it. Just wait one moment. Okay, here we are. So I did find one reference. It's not perfect, but it's good enough. I've just copied it across, copied the sketch across, turned it into a block, so I don't have to worry about dimensions. Just put a circle construction line around it to work as a bit of a placing guide. I did mark the center point in my dimensions there at 29, so I can put that in. And I'm going to suggest that it's centered on this line. Again, it doesn't need to be perfect. And then what I can do in the sketch is a linear pattern. These were 45 millimeters apart, so I can put that in, dimension that, and then we have what looks to be a pretty good estimation of those power outlets. Now there's nothing else that I need to put in this top view, so we're going to press OK on that, and what we'll do now, we'll leave that view there, we'll do another top view. I'm just going to select chain and convert that outside edge, and I'm going to extrude this up to create the shape. So we're going 25 millimeters up, and then we can see that there's a couple of radiuses on this. So at the back, let's hide that sketch, and let's just save this. We'll save it in this folder. This is a HBM 4.4 slot Powerboard. Okay, I measured a radius of 10. At the back, let's just put that on there. Forgot to change the dimension. Okay, 10. I also measured a 3mm chamfer on the top. Now, I haven't done that cut through yet. So that is one thing I might do. I measured that cut through as We'll just measurement down here. Let's just go to the video, okay, and see where we took a dimension of that top face. Okay, so what we're looking at here is I've actually measured the height of that section. It's 29, so it's +4. I don't have the distance that comes in. That's not actually important here because it's not going to impact our mounting ability. It's just purely for show. So I'm just going to raise the height of my extrude up 4 millimeters. I'm going to do that chamfer that's continuous all the way around. And then I'm going to do that little cut down to reduce that section that you can see I'm moving my finger over here. So let's do it. So that's going to go to 29. I said it was like a 3 millimeter chamfer. Now it's not necessarily 45 degrees. Let's see if we get a side profile. Yeah, you can see it here. It's like a bit lower than that. So it might be like 60, 3 millimeters. And what's tricky here is that it cuts away, and that's all flat, but the chamfer doesn't move. It's actually very little intricate detail, which I don't want to spend that much time on. So let's have a look here. We're going to show that sketch. Select chain, convert, select this edge, convert, trim away the excess, hide. Now if we extrude cut 4 millimeters, it's going to look a bit funny because it's not really an extrude cut. It's this is all definitely lower, and it kind of works in a curve. Yeah, not like that at all. No, it's not like that. How's this slicer? Now I'm intrigued and I want to get this geometry right. So I don't think it's actually flat. You can see how the light kind of curves across the top, and that curves across the top. That would suggest that there's an actual rise in the middle. And we cut away that's what we get. So just come back to 25, and we just want to raise for that where that 29 is, there to there. Slide, it rolls up and then across. So rolling up here like this, rolling across straight, and it's a gentle curve down back into that surface. I think it's going to be something like this. So let's just get it right. When I say get it right, let's just get it fully defined, just so we get a little bit of control. It's not necessarily tangent. I'm going to kind of blend it in. Nice and tricky one. Gonna have to do another sketch, aren't I? Oh, fuck. Flat. Curve up across. So from 0 to 4, back down. My chamfer is definitely wrong. That's better. 3 mil, 30 degrees. And that edge. So what I'm looking at here is this edge. So here it's at its highest point in the middle, and then it comes down to, it joins up here tangent. So it's obviously going from like a 0 height to a 4 height around in this shape. And it's on not the outside edge, but the inside edge. And so that's one place where this sketch was wrong originally. That sketch, this one here, this one actually needs to offset, whatever that distance is, which I can do. Okay, so I can just draw this, make it tangent to that edge, split it, and I'm also going to make that for construction as well because I don't need any of it. And then let's try like a projected curve onto this face. Okay, so now that curve gives us sort of what we need. We can also use that instead of a projected curve. Actually, let's just split the face. Okay, that looks better. And I think I want to delete the rest. I'm just going to delete these faces. Just leave the curve. I don't want to patch anything. Just delete. So I'm leaving a surface there. All right, so you see how that surface comes up, goes back down. All right, and then it's that surface that merges out with those other faces. So maybe we can put a guide curve in here. So we'll just put a bit of straight and then some gentle curve down. So that's going to match in there and there. Let's give it a length, let's say 12. All right, so now we're just sort of building out that little space. We'll try now a surface, a lofted surface. We're going to go from this sketch to these two edges. Not quite. Let's do another sketch here. Let's convert those. Let's split, get rid of that, and get rid of that half. All right, so we're just creating now some guidelines. This could be a filled surface from this sketch to this sketch to this edge. You can see the preview. We can go, are any of them tangent? Only the one in the middle, but there's no guide there. Contact, yeah, can't use that. Actually, we will change the plan again. We'll make this sketch all the way around. Can't drag. Okay, so I've got an inside and an outside. Let's try again. Filled surface. This edge to this sketch. And constraint curve, going to be this. Mesh preview, not bad. Merge result, fix up boundary. Let's just merge result. Okay, then we can thicken and merge with the main body. And there we go. That's how we create that little detail. Just going to get rid of whatever's on the inside. There we go. All right, took a little bit longer than I would have liked, and it's not perfect. So it's got a bit of a bump here, but for what we're doing, I think that's fine. Okay, let's continue. I have those holes to do, so let's just put those in, just so we know where they are. Okay, makes that one over there look a bit off, doesn't it? We said it was a placeholder. Let's change it to 20. Doesn't want to do it. I don't really want to do this again. Okay, 24. That'll do. All right, that was the front. We're also going to put in cable point. Cable point being on this face. We measured it at 8. I think 8 would have been the end. And if we just have a look in the video to see that end, it's on the split line. Let's put our split line in first. To do our split line, we will do just a simple cut. I'm just going to do a circle. This is a pretty cheap way of doing it. I know it was 8mm down from the top face at this end. So just done a little circle there. And what I'm going to do is use that circle and then do a swept cut and use something that goes consistently all around the product, which would be any of these edges here, like this chamfer. I'm going to go selection manager, tangent, continue. Is it going to work? Ooh, okay, doesn't want to do it. Cut sweep. Let's try a sweep instead. We can create a solid body. No, it wants it to be on the profile, on the path. That's annoying, but we can do that. We can fix that. Let's do it this way. Let's use this sketch, this one. Let's do a swept cut using that profile. Still doesn't want to do it. Okay, bit rusty with my sweep cuts. We're going to do a plane, which is from this face to this face. On this plane, we're going to do an intersection curve, which goes all the way around. All right, now there should be no issues. Select those two sketches and do swept cut. It should pick which one is the profile and which one is the path, which it's done. Press OK. And then we have a part line. Pretty small, simple one. You could do a square. In fact, I will do a square. I'll just change this. Let's make it 0.2 by 1. Just look a bit more realistic. Okay, very good. There is our part line. Now we're going to use that because on this end is our cable, and it's right in the middle of that part line. We measure that as 8, and it's just going to come out a little bit. So let's just extrude it out till we can see it. About there. That's fine. I imagine the cable's about 6. We'll just have that there for reference. There was a button on this face. That button was inside a hole which was 8mm. That's all we're going to measure here, and it was 36 from the end. So I'm just going to put the hole in so we know where that button is. I'm not actually going to detail any button. Alright, that's everything on the front. Let's do the keyholes on the back. Now for this, let's refer to our drawing here. I'm just going to zoom in. So we've got all our important dimensions, except we've got no reference location. We've dimensioned them here. Yeah. Looks like I missed that dimension. And the 2 slots point away from the cable. So we're kind of upside down here, so we'll want to work on that too. So we'll flip it around. Let's draw a 7.1 for the big hole, and then I'm just going to draw it as a straight slot. 4.1 divided by 2, and it is 11.9 from end to end, and there's 2 of those. Now I said they're pointing away from the cable, so we just make these equal slots. Okay, now were they in the middle? No, so we rushed a bit. Let's go and get those dimensions. All right, got those missing dimensions, so I can fit them in. The top side here is approximately 12.2 from the edge, and from the close edge here to this outside edge is 46.5, and that fully defines that sketch. And we know from point to point, which we'll sort in a second, we can go, we'll do that in our next sketch, I think. Now to keep things simple, I'm just going to convert that sketch just to trim away everything I don't need. I don't want to do this in the one that I've dimensioned because I want to keep those dimensions there. All right, but this way I keep a fully defined sketch, and now I can just go and select that and do a linear pattern. Just going to make it 120, not going to dimension it, I'm going to dimension it in this way here. That's how I measured it, which was the 103.2. And then we can do a cut. For the cut, let's make it 1.5 down, and then we're going to do another cut beneath both of them to kind of symbolize the what it's like with the actual keyhole. So this one can go down another 2. What do we say? 4.7, 1.5. There we go, 3.2. Now that is looking like our sample. So cable coming out one way, are we upside down? I think we are. We want to mirror them. Okay, let's do that. Should be actually kind of straightforward here. So what we're going to do is flip them around. I'm not going to delete any sketches. That way we should be able to retain it in the converted one. I'm going to try and rotate this one here. Doesn't want to because of that dimension. Oh, goodness. Let's fix this for a second. Nope, don't want to do that. Let's fix this. Nope, I can't fix anything. God. Let's fix that dimension. Just gonna delete that equal for a second. Does not want to turn around. Why not? Maybe because of that. There we go. That was a bit harder than I would have liked. Did we keep the dimension for them? Nope, we have to do that again. Okay, so from here to here, 11.9, and then it's from edge to edge, 12.2. Okay, let's see if this works. Yep, all right, so that looks better. I'm not worried about that other hole, not worried about those other points, because I'm only going to use the keyholes. All right, that's looking really good. I did check out this surface while I was down there, so I can just update this curve here. There's no straight section, it's all just one shape that starts horizontal. So just going to put that in, see if that doesn't create some errors. No, that looks a lot better. That looks nicer. Cable is 7. All right, and that powerboard is done. So what are we going to do next? Let me show you. Here's my house, and here is my garage, and here are my workbenches. I need to add the pegboard dimensions, and then I'm going to design a mounting bracket to hold this powerboard to this pegboard using keyhole slots and 3D printing. So stay tuned. So that's what we're going to do next. Thanks for watching this video. I hope you found it helpful and found something new to enhance your SolidWorks skills. Don't forget to subscribe to Fully Defined for more tutorials, tips and insights from a certified SolidWorks expert. Hit the bell icon so you never miss an update. If you have any questions or topics you'd like me to cover, leave a comment below. I read all comments and love hearing your feedback. Remember, with the right skills and tools, you can turn your design dreams into reality. Keep modeling, keep learning, and always fully defined.